Hi there! So in this video I'm going to be revisiting a topic that I covered earlier. That is integration by substitution. Because I feel that the example I covered wasn't really complicated enough. And I just think that I had not done the concept justice. So here, and with another example, here you probably can't see what to use as your substitution. You're a bit confused. And as a technique to problems of this type, you might find a few of these like in exams or whatever as a standard type of problem. So I got u equal to x minus 7, and now I've got du over dx equals 1, so du equals dx, and also, however, from this I can get that x equals u plus 7. This is given me using this substituting in here, and this substituting in there, with this using this. I can now simplify the integral, so integral x plus 3 over x minus 7 close bracket squared dx equals integral u plus 7 plus 3 over u squared du. Right, so this is a plus 10, and now let's split the fraction. So this is equal to integral of u over u squared plus 10 over u squared du. Okay, well u over u squared, that's just 1 over u. So using some standard integrals and a couple of simple integration rules, and get this is just ln of u. Now, depending on how you think of it, you could say this was an ln of absolute value of u, or just an ln of u. It's a bit debatable depending on your level of course. Some early on courses would just say it's ln u. Some high level may say it's absolute value. But moving on from this, then you've got the 10 over u squared. Well, I can see that's minus 10 over u. And let's not forget the plus c, the arbitrary constant. Okay, so that was another example on integration by parts. Wait a minute though. I might have fooled you by going into my outro, but I still have to substitute for u, which will give me ln of x minus 7 minus 10 over x minus 7 plus c, where c is an arbitrary constant. So that was another more complicated example on integration by parts.